Good morning, afternoon, everyone, whenever you're watching this. We had a snow day today, so we're going to go over the classroom a little bit for Tuesday, 2/16/21. Just wanted to have the opportunity to see how this has worked out and go over the thought process. I strongly advise that you pause the video before going through this or trying to do it yourself. And then anytime I ask a question, pause and try to answer it yourself, because that's going to be more beneficial to you in the long run. So to start off, we are given this figure here on the right, and we're going to be given, I think, 6 questions on it. And what we're going to do is we're going to highlight these triangles as we go through it, and you'll see what I mean. So for question 9, if segment AB is congruent to AE, we want to name 2 congruent angles. So what we're going to do is we're going to highlight segment AB and segment AE. And so we want to draw our figure with the given information. So we have these two, and we're trying to find the congruent angles. What we're going to do is we're going to mark these with tick marks. I completely forgot that. So what type of triangle is this? Triangle ABE. What we have is we have 2 pairs of congruent sides and a third side. So this is an isosceles triangle. And we know that because we have AB congruent to AE. Now think about what you know about isosceles triangles so far. And we need to find out which 2 angles are congruent. So the 2 angles that are congruent are going to be angle ABE, this one right down here, and angle AEB, this angle right down here. And the angles that are congruent are always the angles that are opposite of the congruent sides. And how do we know that these 2 angles are congruent? Take a moment, think about it. It is from the isosceles triangle theorem, which states that if we have a pair of congruent sides, then the angles opposite those sides are congruent. Okay, moving on to number 10. I am going to erase everything here. For problem 10, we're asked if we're given an angle ABF is congruent to angle AFB, we want to name 2 congruent segments. So this is a little bit different than the last one we did. And what we want to do, as always in geometry, you want to draw our figure with the given information. So we have angle ABF, congruent to angle AFB, angle AFB. I should probably mark this angle in blue. We want to name what 2 segments are congruent. And then you ask yourself, what type of triangle is this? This is also an isosceles triangle, and we know that because we have the 2 base angles here congruent, angle ACEF and angle AFB. So then which sides of this isosceles triangle are congruent? We're going to get segments AB and segment AF are congruent to each other. And again, that goes back to the previous question where the sides opposite of the angles are congruent. Then how do you know that these 2 segments are congruent? This should say segments right here. So how do we know that these two segments are congruent here? Segment AB and segment AF. That is going to be the converse of the isosceles triangle theorem, which says if you have a set of congruent angles in a triangle, then the sides opposite those angles are congruent. Okay, for number 11, we're given if segment CA is congruent to segment DA, we want to name two congruent angles. So we're given segment CA and then segment DA are congruent to one another. And if we connect CD here, we get triangle ACD. So again, we want to draw our figure with the given information. You can draw it at home on your paper on the side. On here, I'm just using the highlighter to show you what it looks like with the picture. What type of triangle is this? Notice we have two pairs of congruent sides, so we have another isosceles triangle. We have segment AC congruent to segment AD, which is the definition of isosceles. Which angles are then congruent? For this one, it's going to be angles ACD, right here, and angles ADC. Notice it's the angles opposite of the pair of congruent sides. And then how do you know that these two angles are congruent? Just like in our first problem, you know that by the isosceles triangle theorem. Erases. Problem 12. If angle DAE is congruent to angle DEA, we want to name two congruent segments. So this is like problem 10. And what we're going to do is we're going to do angle DAE. DAE. I'm going to do that in red. I'm going to underline that. We'll do some Christmas colors because of all the snow and ice outside. And angle DEA. So angle DEA. Again, I forgot to mark my angles. I'm sorry for that. And we look at this. So what we want to do is we want to draw out the figure. And we know it's an isosceles triangle. We've dealt with the three of these now. Because we have the two base angles congruent, angle DAE and angle DEA, we know that the sides opposite those angles, or segment DE and segment DA, are congruent to one another. And we know that they're congruent by the converse of the isosceles triangle theorem. So if you need a little bit more time, you can pause the video. For problem 13, we are given if angle BCF is congruent to angle BFC. Name two congruent segments. This is just like the last one. We're going to highlight BCF in red. Angle BCF. And angle BFC. So here's BFC. Angle BCF. And we want to name two congruent segments. Now you might notice a pattern in this. We're just saying it because we're trying to make sure that you get into a habit of drawing the picture or highlighting a picture. Because geometry is so much easier when you can see what you're talking about. Trying to do this abstract is very, very difficult. And there's nothing wrong if you draw a picture because it helps you to see and make sure you're okay, this is what I'm talking about. We have two congruent base angles. So this is an isosceles triangle. I didn't make my screen any smaller so you can see the black behind me. And we know this because of the two congruent base angles, angle BFC and angle BCF. Which sides are then congruent? You can draw a little arrow if you need to. I used to do that when I was in school. And we're going to get segment BF and segment BC, BC and BF, whichever way you want to write them. How do we know these two triangles are congruent? Or these two angles are congruent, rather? I'm sorry, it should be segments. It should be segments are congruent. How do we know these two segments are congruent? Segment BF and segment BC. That is by the converse of the isosceles triangle theorem. Because we're given the angles, therefore we can prove the sides are congruent by the converse. Okay, and our last question for this section. If segment FA is congruent to segment AH, segment FA, going for this nice big triangle right in the middle here, is congruent to segment AH. Name two congruent angles. What we're going to do is we're going to just finish off this triangle here by connecting F and H. So now we have triangle AFH. Again, draw the picture with the given information. We know that this is an isosceles triangle. We know that because of the congruent sides, AF and AH. Then we know that the angles are congruent are the angles opposite of these sides. You have angle AHF and angle AFH. And how do we know these are congruent? We're given these sides in this problem, so we know that the angles are congruent. So we want to use the isosceles triangle theorem. If you need a little bit more time, pause the video. We'll move on to question 15. All right, so for question 15, we want to figure out what the measure of angle BAC is. We have angle BAC here, and we're trying to figure out what the measure is, given that angle B is 60 degrees, and that segments AB and AC are congruent. So using what we're given in this diagram, what do we know about the angle measurements from the given information? Well, we know that angle BAC is congruent to angle BCA. And how do we know that? We know that by the isosceles triangle theorem. So if we can figure out the measure of either one of these, we can figure out the measure of the other, but we also have the measure of angle B right here. So since the sum of the interior angles of a triangle is 180 degrees, we can do some substitution. We know that angle B plus angle A plus angle C, the measures of these angles should give us 180 degrees. So that's what we do here. We do the measure of BAC plus the measure of ACB plus the measure of CBA gives us 180. When we substitute in segment CBA, we get measure of BAC plus the measure of ACB plus 60 equals 180. However, note, since the measure of BAC equals the measure of ACB by the definition of congruent segments, if two segments are congruent, their measures are equal, that means that these two will be the same value. So what we're going to do is we're going to substitute in BAC for ACB here. So you see we go from BAC plus ACB to BAC plus BAC because the measures are the same. And at this point, it's just regular algebra. We then have 2 times the measure of BAC equals 120, or that the measure of angle BAC is 60 degrees. And just an extra point, since the measure of angle BAC is 60 degrees, then the measure of angle ACB is also 60 degrees, which means that we have what kind of triangle here? We would have an equilateral triangle. So the segments would also all be congruent. Problem 16 wants us to find the measure of angle SRT. Given that we have segment ST and RT congruent and the measure of angle T is 50 degrees. So we're trying to find the measure of this angle right here in green. This is going to work a lot like the previous problem. So what do we know about these angle measurements? Just like in the previous problem, we know that angle TSR is congruent to angle TRS. And I'm going to mark that in red here, because we have the congruent sides here. So it's the angles opposite of those sides, or the sides opposite of those angles, depending which theorem you're trying to use. Which theorem supports that? The isosceles triangle theorem, of course. It's our favorite theorem for this section. So just like the previous problem, since the interior angle sum of a triangle is 180 degrees, we're going to do the same type of substitution where we do angle R plus angle S plus angle T equals 180 degrees. I wrote it using the 3-point notation because I like 3-point notation a lot. So angle TRS, angle RST, and angle STR is 180 degrees. This should be a 50. I missed that when I was editing. I'm sorry. And just like the previous problem, since the measure of angle SRT equals the measure of angle TSR, because congruent angles have equal measures. We can substitute in SRT wherever we see TSR. Okay, I just wrote it backward. I started with TRS and wrote it as SRT down here. So these are RST, it's just in a different notation. Then 2 plus the measure of angle SRT equals 130, meaning the measure of angle SRT is 55 degrees. Okay, question 17. This one's given a little bit differently. We have measurements for the sides, and we are given, I'm going to put myself over here. We want to find the length, the measure of segment TR right here. Using what we're given in this diagram, what do we know about the angle measurements from the given information? Now, this one doesn't have the tick marks like the previous one, but we do have another angle measurement here. However, we see that segment PT is 4 and segment PR is 4, meaning that the measure of these lengths, these segments are the same, and therefore they are congruent. And once we have congruent segments, you guessed it, these angles are also going to be congruent. Angle PTR is congruent to angle TRP. Angle TRP. And what theorem or postulate supports this? Remember, we were given the sides. So then this is the isosceles triangle theorem. And much like the other one, since the sum of the interior angles of a triangle is 180 degrees, we're going to take the sum of these three angles, measure of angle RTP, plus the measure of angle TRP, plus the measure of angle TPR is going to equal 180. If you look at it, we need the measure of TR, but we don't have any kind of information to tell us what this is. What we need to do is figure out the angle measurements to try to prove that. Because all we're given are these two sides congruent. And what we're going to see is the measure of RTP plus TRP plus 60 degrees equals 180. That's by substituting 60 in for TPR. Since the measure of RTP equals the measure of TRP, we're going to substitute that in. We're going to get measure of RTP plus RTP because we substituted RTP wherever we saw TRP equals, it should be 120. Two times the measure of angle RTP equals 120 degrees. Therefore, the measure of RTP is 60 degrees. But we're not quite out of the woods yet because this isn't what we were asked to solve for. We were asked to solve for segment TR. And all we're given now is that we have a triangle with three 60-degree measures. So then what kind of triangle is this? Well, it's an equiangular triangle because we have 60, 60, 60. And then a little bit later, past the isosceles triangles, what do we know about the measures of the sides of an equiangular triangle? They're all the same. Since it's equiangular, it's also equilateral, which means that segment TR is congruent to segment PR. That's congruent to segment PT. Therefore, the measure of segment TR is 4. All right, and the last one of these, erase all the beautiful markings. I'll put myself back in the corner. There we go. We want to find the measure of segment CB. CB. I don't know why it's not working. Well, we want to find this measure of segment CB. And so look at this triangle. And what do you see? So we look at this. What do we know about the angle measurements? Well, first off, we know the angle C is 70 degrees. And we know that because we have 55, 55. So the sum of the interior angles of a triangle is 180 degrees. So if you do 180 minus 55 minus 55, you're going to get 70. Okay, it's working again. It's really weird. Now it's not working again. We also know that CA and CB are congruent because we have congruent angle segments here. We know that the sides opposite of those angles, segment CB and segment CA, are congruent because the 55 degrees corresponds to that and the 55 degrees corresponds to this. Meaning we have a much easier question this time by using the converse of the isosceles triangle theorem, we know if the base angles are congruent, then the sides opposite those base angles are congruent. Therefore, the measure of CB is 3. Okay, for the next 4 problems, we are given this figure, and we want to find out different angle or side measurements in this figure. So for question 29, we are asked to find the measure of angle CAD. So we know the measure of angle ADC, or angle D, is 92 degrees. That's right here. And much like the other problems we've been dealing with in the last 4 or so, we need to figure out what we know about the other angles in this figure. We know that angle CAD and angle ACD are congruent. Because right here, we have double tick marks, which means that the angles opposite of these sides, if you hear my puppy, there's a cat running around upstairs. So we know these are congruent. And what's the formal theorem or postulate? This is by the isosceles triangle theorem. We're given 2 pairs of congruent sides. Therefore, the angles opposite those sides must be congruent. Then that means that the measure of angle CAD plus the measure of angle ACD plus the measure of angle ADC must be 180 degrees. Since angle CAD and ACD are congruent, we're going to substitute this in. So anywhere we saw ACD, we're going to plug in CAD plus the 92 degrees at ADC. 2 times the measure of angle CAD equals 88. We subtracted 92 from both sides. And then the measure of angle CAD is 44 degrees. Likewise, so because we have these 2 angle measurements are congruent to each other because of the opposite sides, I should actually finish drawing the triangle so we can see it. So we have the angles opposite of these sides must be congruent, meaning that the measure of angle ACD is also 44 degrees. That's pretty cool how that syncs up. So now that we filled in that information, we're going to question 30. Because this problem is going to keep building upon itself, we may as well just write down the angles or sides that we figure out in the previous section. It's going to make it a little bit easier moving forward. Question 30 asks us to find the measure of angle ACD, which conveniently enough, we did in the last question. We know that ADC is 92 degrees and that CAD is 44 degrees. So how do we know that the measure of ACD is 44 degrees? Well, we could do the base angles of an isosceles triangle are congruent. That is a definition. Or if you want to take the algebraic route, you could do angle D plus angle DAC plus angle ACD equals 180. And you would find out that ACD is 44 degrees. But I opted to use the information that we were given in the last section, or in the last problem, I'm sorry, and save myself a little bit of time. For question 31, we want to find the measure of angle ACB. So that is this angle right here. Now there's 2 ways that you can do this one. We know that segment DB is a straight angle. So our first method is we can take the measure of angle ACB is equal to the measure of angle CAD plus the measure of angle D. So the exterior angle of a triangle is the measure of the exterior angle of a triangle is equal to the sum of the other 2 angles. So if we add 44 and 92 by plugging them in, CAD and measure of angle D, we'll get the measure of angle ACB is 136 degrees. The other way we can do that, and this one is my preferred method, is to take the measure of angle ACD and the measure of angle ACB and set it equal to 180. And don't get me wrong, both ways are right. Both ways will get you the exact same answer. You can choose whichever way is easier for you. I just prefer this way. You might have done it, you might have done it with method 1, and that is totally valid. But no matter which way you do it, you're going to get the measure of angle ACB is 136 degrees. So then we move on, we write 136, and we go on to our last question using this triangle. We want to find the measure of angle ABC. So angle ABC right here. Well, we know that angle ACB is 136 degrees. And what do you know about the other angles in this figure? Take a look at the triangle here. I guess I'll just highlight the whole thing in blue. Look at triangle ACB here. And what you'll notice is you have tick marks along segment CB and segment AC. And we have tick marks showing that segments and sides are congruent. Then we know that angle CAB and angle ABC are congruent, because the angles opposite these sides. Meaning, like we've done with so many problems. Well, before we do that, how do we know that? That's the isosceles triangles theorem. Get used to using these theorems. You're going to need them in your proofs. Then this means we can use algebra again. Measure of angle CAB plus the measure of angle ABC plus the measure of angle ACB equals 180. Since angle CAB and ABC are congruent, we're going to plug in ABC everywhere we saw CAB. And we plug in the 136 where we had ACB. Do some algebra, we get 2 times the measure of ABC. This should be ABC right here. Two times measure of angle ABC equals 44. And the measure of angle ABC, all right, a really nice this time, equals 22 degrees. We have one problem left, so let us get to it. Okay, for our last problem, we have a proof. We're given that segment WX is congruent to segment WV, and that segment ZY is perpendicular to YV. We want to prove that angle X and angle YZV are complementary. So a good idea when you're doing this is to brain dump and try to write down anything that you know just by looking at the diagram, and then try and figure out how to piece it together a little bit later. First off, what we know we want to look at is define complementary. So it means that's going to have a sum of 90 degrees, the measures of these angles. So what we're going to prove is that the measure of angle X plus the measure of angle YZV equals 90 degrees. Then looking at this problem, okay, we see we have 2 congruent segments, segment WX and segment WV. And one thing we've been seeing a lot lately is that we're going to be using the isosceles triangle theorem. So just by those congruent segments, we also know that angle WXV is congruent to angle WVX. We also see that angle WVX here has a vertical angle with YVZ. So angle WVX and angle, this is very hard to draw with a mouse, YVZ are vertical angles. We also see we're going to have perpendicular lines. We know that perpendicular lines form congruent angles. And that perpendicular lines also have angle measurements equal to 90 degrees. So looking at this, we have some congruent angles, we have vertical angles, we have perpendicular lines. Given that we're trying to prove that two angles are complementary, I think we have a good start to move forward. And what we're going to do with most proofs is we're going to look at our first bit of given information and try to derive everything we can from that. So we're given that segment WX is congruent to segment WV, and that's given to us. And what we stated earlier is that angle X is congruent to angle WVX. And because we were given the two sides and not the two angles, our reason is the isosceles triangle theorem. Now that we've used that bit of information, I'm going to scratch that off over here from our brain dump. We might not use all of it, but it's good to have it down. When we're trying to think of how to solve a proof, you want to look at, okay, I'm looking for angle measurements, so I'm going to be looking to show angle congruency. If we're looking for a congruent segment, I'm looking to use possibly CP, and find triangles in there. Now, we also saw that we had a vertical angle here. We had angle WVX and angle YVZ, our vertical angles. So because they're vertical, it means that these two angles are also congruent by the vertical angles theorem. So we use our vertical angles right here. Now, what's interesting about this is you could have done 2 or 3 in either way. You could have said that the vertical angles are congruent, or you could have said that the isosceles triangles theorem applied. In 3, in 2, it didn't matter. What's important is you need both of these statements before you start doing our next step. So notice we have angle X is congruent to angle WVX. And we have WVX is congruent to angle YVZ. And if you look at our diagram, they're all marked with the same teal tick mark, which allows us to say that angle X is congruent to angle YVZ, and that's by the transitive property. And that's basically saying if A equals B and B equals C, then A equals C. We're just applying it to geometry now. So now we've gotten an angle measurement in our second little triangle YVZ here. And now that we've done that, we want to, we've done everything we can with these segments. We have nothing else that we can actually derive right now. So what we're going to do is we're going to jump to our second bit of information, which is that segment ZY is perpendicular to segment YV. And that information was given to us. Now we know that there's an angle formed here, angle VYZ or angle ZVY. Or angle Y, if you're not using the 3-point notation, is a right angle. Because we know perpendicular lines form right angles. And that bit of information we already dumped down right here. So this gives us another angle measurement, which is we're getting really close to showing that these are complementary. But now, where do you go from here? It's not it's not that obvious at first. So we're like, okay, well, we have a hypotenuse leg. Maybe we want to use hypotenuse leg here. So we're also going to say that triangle ZVY is a right triangle. And that's just by the definition of a right triangle. Okay, so we have an angle. Maybe we can show something with the segment and the hypotenuse. We don't know. Right now, we're looking for anything that we can get. We're trying to get a foothold. We're trying to find some kind of measure for angle YZV right here. What's interesting is now that we know that this angle is 90 degrees, we also know that the sum of the interior angles of a triangle are 180 degrees, which means that angle Z and angle VYZ must add up to 90 degrees. So that means that they're complementary because we already have a 90-degree angle. So these two are also complementary to each other. And that's just by saying the acute angles of a right triangle are complementary. That's always going to be the case for you. And now you might be able to see where we're going with this. Because similar to what we did in statement 4 here with the transitive property, okay, so if they're complementary, it means that their sum is 90 degrees. And that's getting really close to the format that we're trying to prove here. So we have the measure of angle YZV and the measure of angle YVZ is 90 degrees. And that's by the definition of complementary angles. But look what we finally done. We have YVZ and YZV are 90 degrees. And up here, we show that angle X is congruent to angle YVZ. And what we're going to do is we're going to say that the measure of angle X is equal to the measure of YVZ. You could have done this way back up in statement right after statement 4. But we opted not to do it until the end because at this point we're working with the measurements. So because angle X is congruent to angle YVZ, it means that the measure of angle X equals the measure of YVZ. So that's the definition of complementary angles. What we're going to do now is we're going to substitute in where we see YVZ, we're going to substitute the measure of angle X. We now have the measure of angle YZV plus the measure of angle X equals 90 degrees. This is exactly what we're looking for up here in our proof. That's by substitution. If you want, you could write the steps, from statement 10. And then we always finish off with our proof statement. Angle X and angle YZV are complementary because you always want your final statement to be exactly what was given in your proof statement. And that is by the definition of complementary angles. So if you need it, take a moment, pause the video. Have a wonderful rest of your snow day. We'll hopefully see you Thursday bright and early with bells on our toes. Take care, everyone.